This is the solution to question 1 of the higher level 2014 physics paper. So it's the experiment on conservation of momentum. Okay, so there's some details there saying how they carried it out, and we got some data about their results. To draw a label diagram of the apparatus used in the experiment. Okay, that's part 1 anyway. Alright, so I was going to say you should always draw in pencil, not like me, but given the new regulations in the exam, maybe you shouldn't be drawing in pencil. Okay, label everything. That is an air track. Okay, so this is a light gate. I always do it with the air track and the light gate, not the ticker tape timer. Scalar timer. And then there is another light gate here. Connected to another one on the other side over there. And then there is the riders. And that is a card on top of the riders. And just to be picky, there is it's not a vacuum blower, that's what it is. Okay, do I have everything I need? I've got my timers, my light gates, my riders. I'm going to say blue tack is what we always use to stick them together. You could say magnets as well. Just so you're showing that they're not bouncing apart from each other, okay? They're sticking. So you've got blue tack or magnets there in the middle. I hope you can read that now. I'm going a bit small, is it? It's not so bad. Okay. Okay, is that everything? Grand. State what measurements the student took and how these measurements were used to calculate the velocities. Okay, so length of card on rider, they call it body A, the length of card on rider B, time for light gate 1, the time for light gate 2, that's probably it. Like we're given, I was going to say mass balance for mass of riders, because we need that. Okay, velocity equals length of card divided by time recorded. So it's distance over time to get the speeds. Oops, sorry, it went off again. It's a bit of a habit of mine. Right, is that a bit better? Is that in focus? Okay. Yeah, so distance over time. Using the recorded data, show how the experiment verifies the principle of conservation of momentum. Okay, so this is part 3. So m1 v1 plus m2 v2 is going to equal m3 v3 in our case, okay, because we're going to have one thing afterwards. Okay, so mass of body A is, we'll leave it in grams, it's fine. 325, the velocity of A before the collision was 0.84, plus the mass of body B, 349.8 times 0, it wasn't moving, and then the combined mass is 325.1 plus 349.8. The velocity after the collision is 0.41. Okay, so we do 325.1 multiplied by 0.84 gives me 273.084 gram, is it meters per second. We're not counting this, remember, because it's 0, so we don't need to worry about that. And then afterwards I've got 325.1 plus 349.8, add them together, multiply by the velocity, and I get 276.709 gram meters per second. These are roughly equal. Verifying the law of conservation of momentum. Okay. When carrying out the experiment, the student ensures that there is no external force acting on the bodies. Where are the two forces that the student needs to take into account to ensure this? Or what are they? Okay, the student needs to take gravitational force and friction into account. This is done by using a horizontal air track. The track being horizontal ensures that the weight of the riders is not contributing to the velocity. So there's no acceleration due to gravity, essentially, is what I'm trying to say. That there's no effective, net effective, I guess. The air track provides a cushion of air to reduce the effect of friction. I say reduce because there is still friction with the air itself. Okay, cool.